So now I will be presenting about the first subtopic of chapter 5, which is oils and fats. So in this subtopic, there are three learning objectives. The first one, we will be able to compare and contrast oils and fats. Second, we will be able to explain the conversion process of unsaturated fats to saturated fats. And lastly, we will be able to justify the use of oils and fats in daily life. First and foremost, of course, we need to know what is meant by oils and fats. So oils and fats are ester produced through the reaction between fatty acid and glycerol. So now I will be explaining about the esterification reaction. So what is the esterification reaction? Esterification reaction is the reaction between glycerol and fatty acid to form a fat. Okay, so as we all know, fatty acid have a very long carbon chains. The characteristic of oils and fats rely on the type of fatty acid involved in the esterification reaction with glycerol. Some examples of fatty acids are like palmitic acids, stearic acids, and also linoleic acids. So as we can see in the figure 5.1 below, it is the example of the esterification reaction between glycerol and fatty acids to form a fat. So you must be wondering, how does the esterification reaction work? Okay, so it only took one glycerol molecule to react with the other three fatty acid molecules to form one fat. Okay, so in the figure below, we could see there are R1, R2, and R3. R1, R2, and R2 represent the hydrocarbon chains that contain in the fatty acid or fats. Okay, so R1, R2, and R3 could be identical or different with one another. So now I will be talking about the difference between oils and fats. So, in the aspect of source, oils come from the plants while fats come from the animals. And also the physical state of oils and fats at table temperature are also different. Oils are liquid while fats are solid. Oils have a very low melting point compared to the fats. And also, oils have a very high percentage of unsaturated fatty acid, while fats have a very high percentage of saturated fatty acid. Example of oils are palm oil, olive oil, and so on. And fats, the example of fats are like butter or even animal meats. So now I'll be talking about the saturated and unsaturated fats. So what is saturated fats? It contains saturated fatty acids. Some example of saturated fatty acid are palmitic acid, lauric acid, and also stearic acid. Saturated fats only have a single carbon bond in the carbon chain. As you can see down here, this is the carbon chain of saturated fatty acid. So let's move to unsaturated fats. So in the unsaturated fats, it contains unsaturated fatty acid. Some example of unsaturated fatty acid are oleic acid, linoleic acid, and also linoleic acid. In the unsaturated fats, it have at least one double bond in the carbon chain. As you can see down there, that is the carbon chain of the unsaturated fatty acids. So, the presence of double bond causes unsaturated fats to have a low melting point and exist as liquids. So now I will be talking about the conversion of unsaturated fats to saturated fats. So what is the name of the reaction of the conversion of unsaturated fats to saturated fats? It is called the hydrogenation reaction. What is the hydrogenation reaction? So unsaturated fats are converted into saturated fats through this reaction. During this hydrogenation reaction, hydrogen gas H2 is passed into oil with the presence of nickel as the catalyst. So the double bond in the carbon chain is so called to be opened, and the hydrogen atoms H are added to the carbon chain. So in figure 5.3, as you can see down there, is the example of the hydrogenation reaction of unsaturated fats to the saturated fats. So now lastly, I'll be talking about the uses of oils and fats in daily life. So first, it is for the biofuel. So oil are used to produce biofuels such as biodiesel to be used by bicycle with diesel engine. Second, it also could be the nutritional source for humans. It is to supply energy and help the body to absorb important vitamins such as vitamins A, D, E, and K. Third, oils and fats are used to make soap and personal care. It is the main ingredient for soap making. Personal care items like skin moisturizer also utilize oil in their production. And lastly, oils and fats are used for animal feeds. It is used to manufacture feeds to cattle to fulfill their nutritional needs.
Hi everybody! Now I would like to talk about cleaning agents. There are two different kinds of cleaning agent, soap and detergent. What is soap? Soaps are sodium or potassium fatty acids. Soaps are produced from neutralization reaction between fatty acid and alkalis. Fatty acids are long-chain carboxylic acids, and the general formula is RCOO Na or RCOOK+. R is an alkyl group containing at least 8 carbon atoms. R consists of saturated or unsaturated hydrocarbons. Next, we will talk about detergent. Detergent is a non-soap cleaning agent. Detergents are sodium salts of sulfonic acid. To make detergent, there are two types of sulfonic acid that need to be used: alkyl sulfonic acid and alkyl benzene sulfonic acid. Detergent usually are made from synthetic sources such as petroleum fractions. Have you ever wondered how to prepare a soap? Soap can be prepared from natural sources through hydrolysis of oils and fats in sodium hydroxide or potassium hydroxide. This reaction name is saponification, which is the process of hydrolysis of oils or fats by alkalis. This is the general equation of saponification reaction. Oils and fats are natural ester alkaline. Hydrolysis on triglyceride will produce glycerol and soap as shown here. Okay, now I will talk about preparation of detergent. Detergents are usually made of petroleum fraction and sulfuric acids. Detergent can be produced through two processes, which are sulfonation and neutralization. For example, preparation of sodium alkyl benzene sulfonate. Alkyl benzene reacts with concentrated sulfuric acid to form alkyl benzene sulfonic acids. The next example is preparation of sodium alkyl benzene sulfonate through neutralization. Alkyl benzene sulfonic acid will be neutralized by sodium hydroxide solution to produce alkyl benzene sulfonate salt, which is detergent. What about the cleansing action of soap and detergent? When soap or detergent is dissolved in water, their molecules dissolve to form sodium ion or potassium ion and soap anion or detergent anion. First, adding soap or detergent into the water will reduce the surface tension of the water. This increases the water's ability to wet the surface of the clothes. Second, soap or detergent will ionize in water to produce free-moving soap anions or detergent anions. The hydrophilic parts of soap anions or detergents anions dissolve in water while the hydrophobic parts dissolve in the grease. Movement of water during scrubbing and agitation causes grease to pull away from the cloth surface. The hydrophilic parts of soap or detergent anions surround the grease and floats to the surface of the water. Next, grease will break into small droplets. The droplets will not reattach to the cloth surface due to the repulsion of negative charge of the hydrophilic parts on the surface of the grease. And lastly, the droplets are suspended in water, forming an emulsion. Rinsing with water causes the cloth surface become clean as the grease droplets are washed away with the water.
Now, let's move on to the food additive. Food additive can be defined as food, natural or synthetic substances added to food to improve their taste, appearance, shelf life, or nutritional value. So, these are the type of food additive and their function. First, preservative, to extend the shelf life by preventing microbial growth such as bacteria, yeast, and mold. For example, benzoic acid and sodium nitrate. Number 2, antioxidant, to prevent oxidation that causes rancidity or spoilage of food. For example, vitamin C and vitamin E. Number 3, flavoring agents, to enhance or add flavor to food. For example, vitamin D and iron. Here are some advantages and disadvantages of food additive. Advantages of food additive is to prolong shelf life, reducing food waste, enhance flavor, color, and texture. And one of the disadvantages of food additives is overconsumption of certain activities like MSG can cause allergies to health, and also overuse of flavor enhancers can lead to dependency.
What is medicine? Medicine is chemical used to help with the treatment or prevention of disease. Medicine has a two type, which is traditional and modern. Traditional medicine is obtained from herbal plant or animal, are not chemically processed. Nowadays, traditional medicine have evolved through processing and marketed in the form of pill and capsule. For modern medicine, its rapid development in the field of medicine through technologies such as biotechnology, nanotechnology, and genetic engineering have boosted the production of modern medicine in the pharmaceutical industry. This is example for traditional medicine such as tamarind, ginseng, and aloe vera. And this are some examples for a modern medicine such as analgesic, psychotic drugs, and corticosteroid. This is the function of the traditional medicine. For ginseng, it can be immunity against infection, lower blood pressure, and cholesterol level. For aloe vera, it can treat a skin disease and treating a burn. And finally, tamarind. Juice of the fruit can relieve a cough and brighten the skin. This is the function of modern medicine. For analgesic, aspirin and paracetamol are able to relieve pain in occasion pain. Codeine can relieve pain, relieve cough, and treat diarrhea. For psychotic drug, it's given to patient treatment for psychosis, which is a symptom of a mental illness that causes the patient to see, hear, and believe something that is not true. And finally, corticosteroid is a given relief to the inflamed area and can reduce swelling, redness, itching, allergic reaction, asthma, and arthritis. Here the drug efficacy and abuse. Modern and traditional medicine can both treat many of the same illness, although the efficacy level may differ. The wrong dosage can cause undesirable effect and can lead to drug abuse. Drug abuse does not only concern modern medicine, but traditional medicine too. The National Traditional and Complementary Medicine Policy is also introduced to ensure that traditional medicine and treatment are safe and post quality. The National Pharmaceutical Regulatory Agency (NPRA) is a body responsible for the supervision of drug safety and quality control of cosmetics in Malaysia. Now let's move to cosmetics. Cosmetics are material or product that use externally to clean, protect, or enhance one's appearance. Various types of ingredients are used in the production of cosmetics so that the desired effects are obtained. Nonetheless, basic ingredients for cosmetics are normally derived from combination of substances such as water, emulsifier, thickeners, dye, moisturizer, and preservative. Here is the basic ingredient in the cosmetic, such as dye, give a color to cosmetic to make them more attractive, and water is a solvent in the cosmetic production process. So emulsifier is a form homogeneous mixture between oil and water. Thickness it thicken the cosmetic product. And fragrance give a pleasant smell to cosmetic, such as perfume. And the moisturizer is a retain to moisture in the cosmetic product, such as moisturizer in our foundation. And lastly, preservative prevents cosmetic product from spoiling. There are three types of cosmetic. Makeup cosmetic to beautify the face. The treatment cosmetic is to treat the body care, and the fragrance to provide the fragrance. Here is some advantages of making a homemade cosmetic. It is easy to produce using a natural ingredients, safe and free from the harmful chemical, and also it's a low cost. Here, the disadvantages of the commercial cosmetic is leading to the harmful side effect, harmful chemicals that are illegally added, and the excessive claim scent misleading the advertisement. And here is some example that the chemical illegally is added, such as a mercury. It's a very bad to our skin because it can make our skin barrier is very bad. Yeah, so we need to be careful with our product that we are using. Okay.
Hi everyone. Today I want to present about application of nanotechnology in industry. So let's go. So we continue for definition. So what is definition of nanoscience? Nanoscience is study on the processing of substance at the nanoscale that is between 1 nanometer to 100 nanometer. Definition of nanotechnology, development of substance or gadget using the properties of a nanoparticle. There are 6 applications of nanotechnology in the daily life. The first one is semiconductor and electronic. It is smaller and more efficient semiconductor. It is also have high conductivity wiring system. Second one is energy and electricity. It is smaller and more efficient solar cell. It also have long-lasting battery. And the third one is textile. It is water, fire and dust resistant fabric. It is also have anti-wrinkle and UV protective fabric. Fourth, we have a medical. It is highly sensitive testing device. It is also have more effective drug delivery system. And the next one is agriculture. It is more effective pesticide. It also have highly efficient and true fertilization. And the last one is a food. It is nanoscale food additive. It also have antimicrobial food packaging. So next we go to development in the field of nanotechnology. So the coverage of the field of nanotechnology is very wide, covering various disciplines including 6 things: physics, chemistry, biology, medicine and engineering. These contribute to the rapid research and development and application of nanotechnology in various aspects of life. For example, is graphene. Graphene is one of the allotropes for carbon beside diamond and graphite. Yet they have very different properties from each other. The 0.1 mm size of graphene make graphene one of the important materials in the field of nanoscience and nanotechnology. Graphene sheet can produce a variety of other materials including graphite, carbon monotubes, fluorine bolts. There are 6 physical properties of graphene. So we go to the chemical properties of graphene. Graphene sheet burn at a lower temperature than graphite. Graphene is the most reactive carbon allotropes. The chemical reaction of graphene is still being studied by research. So now we go to the last part of the subtopic, which is the use of graphene. There are 6 uses of graphene. First is electronic. It is the arrangement of atoms in the graphene make it a superior conductor. Second one is a sensor. Graphene has a high surface area. And the third one is a biomedical. It is also have a sensor, tissue engineering, drug delivery system. Third, we have a polymer and composite. It is the high mechanical strength make graphene suitable as a polymer composite material. The next one is a membrane. It is water filtration. It also have separation of water from gas mixture. And the last one is energy. It is longer lasting, flexible and powerful battery. It is also have supercapacitor.
Next is application of green technology. What is green technology? Green technology refers to environmentally friendly methods and techniques used to reduce pollution, conserve natural resources, and minimize harm to the environment. In industrial waste management, green technology aims to manage waste sustainably, reduce the impact of industrial activities and the environment. There are a lot of sources of industrial waste, such as chemical industry, manufacturing industry, and agricultural-based industries. So there are applications of green technology in industrial waste management. There are 3R concept, bioremediation, and waste to energy WTE technology. Benefits of green technology in waste management is to reduce pollution, conserve natural resources, minimize environmental, generates renewable energy, and lowers operation costs through waste reduction and recycling. On top of that, there are also challenges in implementing green technology, such as high initial costs, lack of awareness, and resistance to change from conventional practices.